All right. We're looking at this warm-up question. It says the length scale between a model and a real building is 1 to 200. The building in real life has a volume of 30 cubic meters. What is the volume of the model in cubic centimeters? And I haven't checked to make sure these numbers will work out really nicely, but it doesn't matter because we can still solve this even if we're going to have lots of decimals and even if it doesn't work out really well for us. But the first thing I want to do is just kind of give myself a visual and summarize the information. So we've got a scale, or this is the model, and then we've got the building in real life. This is real life. And we're told it is a 1 to 200 length scale. 1 to 200. And just maybe pause the video and remind yourself, what does that mean? When you have it saying the length scale is 1 to 200, just pause the video and try and figure out what does that actually mean. And if you do that, you'll realize, remember, okay, that means 1 unit of length in this model results in 200 units of length in this model. So if something over here is 1 millimeter, over here that same thing would be 200 millimeters. If something over here is just 1 meter long, over here it would be 200 meters long. And if maybe something over here is only 1 centimeter long, well, in real life it's going to be 200 centimeters long. So just keep that in mind as we start solving this question. The other thing we're told, so we know the length scale, model in real life, and it says the building in real life has a volume of 30 cubic meters. So volume equals 30 meters cubed. And we're asked for what is the volume of the model in centimeters cubed. So over here I have the volume is how many centimeters cubed. So this is just kind of a summary of what we need to figure out. So the first thing, this is a question about volume, so that's usually a really good hint that I want volume scale. So first thing let's do is let's find volume scale. Because if I know the comparison of the two volumes, well then I can start solving the question involving volume. And we remind ourselves, volume is cubed, so volume scale is your length scale, LS, length scale, to the power of 3. And my length scale was 1 to 200. So I'm taking my length scale, volume is cubed, so we put that to the power of 3, and my volume scale becomes 1 times 1 times 1 is still 1, and 200 times 200 times 200 again, I think that will be 8 million. And I'm going to cheat a little bit. I'm going to do 200 times 200 on the calculator just to make sure. 200 to the power of 3 gives me 1, 2, 3, 4, 5, 6. Yes, it is 8 million. So what this is communicating to me is if I have one little, unit of volume over here, it's going to be 8 million cubic units over here. So let's say I have 1 cubic centimeter over in this drawing. That would actually be 8 million cubic centimeters over here. And just to review and show off our scientific notation skills, 8 million is the same as 8 times 10 to the power of 6. So these just mean the same thing. We're just showing off that we remember scientific notation. All right, good. So we have that. Now from here, there's a few steps we can take. There's different paths we can take to get the answer. But right now, my volume here is in meters cubed, and I'm told I want the answer in the model in centimeters cubed. So for me, I like to, at this point, change my volume from meters cubed into centimeters cubed. You don't have to do that right now, but that's just the path I'm going to take. So let's find out 30 meters cubed equals how many centimeters cubed. And if we remember, King Henry died by drinking chocolate milk. We have meter, then we have decimeter, and then we have centimeter. So meter, King Henry died by drinking chocolate milk, so that's good. And then we remind ourselves when we're converting with volume, we're not going to multiply and divide by 10, we have to multiply and divide by 1,000. So from meter to decimeter is 2 steps, so I'm going to multiply by 1,000 once and by 1,000 twice because I'm converting with volume. So I say, okay, it's 30 meters cubed times 1,000 once and times 1,000 twice, and that gives me 3, obviously, with 1, 2, 3, 4, 5, 6, 7 zeros, so 30 million. So I have 30 million, this is now centimeters cubed, or if I want to show off my scientific notation skills, that's 3 times 10 to the 7 centimeters cubed. So this is the volume of the building in real life, which seems pretty big. So in real life, this building can hold 30 million little cubic centimeters. And so now our final step is, well, the volume scale, 1 cubic centimeter in this picture is 8 million cubic centimeters over here. So if I have 30 million cubic centimeters over here, how many 8 millions fit in here? Because each 8 million cubic centimeters results in just 1 cubic centimeter over on this side. So to find the volume of my model, I have to say take the volume of the building. The building is 8 million times bigger. So find volume of model. So we take the volume in centimeters cubed, so it's 3 times 10 to the 7 centimeters cubed in real life. We have to divide this by 8 million because this is 8 million times bigger than the model. So divided by 8 times 10 to the 6. And now I know you guys are really, really smart. You can do this without a calculator, but I'm going to cheat a bit with a calculator. You don't have to use scientific notation. You can use the whole number. Just do 30 million divided by 8 million. Get your answer. So 30 million, 30, 1, 2, 3, 4, 5, 6, 7, divided by 8 million gives me 3.75 centimeters. This was in centimeters cubed. It's 8 million times smaller, so I end up with 3.75 cubic centimeters. So that model is actually really, really small, but this is our answer. The model is 3.75 centimeters cubed. And we should actually specify the model's volume. This centimeters cubed already means volume, but the model's volume is 3.75 centimeters cubed. All right, I hope that works. I think that should be the correct answer. And send me a message if you have any questions.